4.1 Quotients of Monomials. So we are going to start off very simple with these. First do the simplifying of one fraction, then move on to fractions that include variables and exponents as well. And then we're going to be doing some that have more than one term as well at some point. So if we look at example 1a, we're starting with 30 over 48. So this is the same thing as saying something like 30 divided by 48. So first what we do, we find the factor that goes into both 30 and 48 evenly. When we know 6, we can divide both numbers by 6. So let's divide both of them by 6. We are left with 5 over 8. We cannot simplify that any further, so that 5 over 8 is our solution. If we look at b, we have 9xy cubed all over 15x squared y squared. So again, we're going to look for the factor that goes into both 9 and 15. They both are divisible by 3, so we'll divide them by 3. The 9 is going to turn into a 3. The 15 turns into a 5. So you're going to have 3 over 5. Then you have your exponents. Remember, with your exponents, when you are dividing them, you are subtracting those exponents. So if we don't have an exponent on a term or a variable, that invisible exponent is 1. Our x's are going to have a 1. We're going to take 2 away from that because the 2 is on the bottom. For our y, we have a 3 on top and a 2 on bottom, so we're going to do 3 minus 2 for those exponents. Once we look at these and simplify those subtractions as our powers, we're going to have 3 over 5. The x is going to be to the power of negative 1, and that y is going to be to the first power. So that negative has to go underneath on the fraction, and the positive stays up top. So this is going to be 3y over 5x. So again, if we have a negative and an exponent, we have to take the reciprocal of that term and bring it to the bottom of that fraction to make that exponent positive. If we look at example C, we have 30a cubed b all over 45ab cubed. So the 30 and the 45, the factor that goes into both of them evenly is 15. 15 goes into 30 twice. 15 goes into 45 3 times. So it's going to be 2 over 3. We have an a cubed on the top and an a to the first power on the bottom. So we're going to do a cubed minus the first. And then we have a b to the first power over b cubed. So that's going to be b to the first minus the third power. So if we simplify these subtractions, we're going to still have the 2/3. We're going to have a to the second power, b to the negative second power. So that positive 2 with the a is going to make it go up top on the fraction. The b to the negative 2, that negative 2 is going to make it go to the bottom of the fraction, and it's going to turn that 2 into a positive. So the 2a squared goes on top, and the 3b squared goes on the bottom. For D, we have 8xyz all over 96 x cubed y z cubed. So we look for a common factor between 8 and 96, which is 8. The 8 is going to turn into a 1. The 96 will turn into a 12. So it's going to be 1 over 12. Then we have x to the first, y to the first, z to the first, x cubed, y to the first, z to the cubed. So that x to the first minus the third, y to the first minus the first, and then z to the first minus the third. So do those subtractions. We're going to have 1 over 12, x to the power of negative 2, y to the power of 0, z to the power of negative 2. That power of 0 cancels out that y, so we're not going to deal with it anymore. The 1 of the 1/12 goes on top. The 12 is going to go on the bottom. The x squared is going to go on the bottom. Same thing with the z squared to make those exponents positive. So we have 1 over 12 x squared z squared. If we look at our next example, we're just simplifying these exponents. So we have a power that's this, we have the base that's the same on both the top and the bottom of our fraction. It's just like if it was a variable raised to that power. So we're going to keep that base and subtract our powers. So if their base is 2 on the top and the bottom, and the top power is 8, bottom power is 5, we're going to subtract those. This is going to be 2 cubed. We can then simplify that by doing 2 times 2 times 2, which gives us 8. Remember, if it tells us to simplify, we simplify fully. So we can't just leave it 2 cubed. We have to simplify that. For b, we have 5x cubed over x to the 7th. So the 5 is going to stay, then x cubed minus the 7th. We're going to have 5x to the power of negative 4. That x to the negative 4 goes on the bottom. That 5 is only attached to the x by multiplication. So you can separate it as saying 5 times x to the power of negative 4. And say, okay, that negative has to go on the bottom. So my 5 is going to stay on top, and that x to the 4th power goes on the bottom. So 5 over x to the 4th power. For c, we have t cubed over 3 all raised to the 2nd power. So when you have something raised to the power and it's a fraction, that power goes to both the top number and the bottom. So this is the same thing as saying t cubed raised to the 2nd power over 3 raised to the 2nd power. The t cubed raised to the 2nd power, remember, if it's a power raised to a power, we multiply those powers. So we're going to do t to the 3rd times the 2nd over 3 raised to the 2nd power. That's 3 times 3, which is going to give us 9. So this is t to the 6th power over 9. If we look at our next set of examples, we have 24s to the 4th power t cubed all over 32st to the 5th power. So again, we can separate this, or we can say 8 goes into both 24 and 32. So I'm going to divide both of these by 8. I'm going to have 3 over 4. I then have an s to the 4th over an s to the 1st. So that's going to be a s to the power of 4 minus the 1st power. And then I have a t to the 3rd minus the 5th as well. So this 3 over 4 is going to stay out front. Then I'm going to have s cubed t to the negative 2nd. So the s cubed is going to go on the top, and the t to the negative 2nd is going to go to the bottom to turn that negative 2 into a positive 2. So the 3 is going to stay on top with the s cubed, and then the 4 goes on the bottom with the t squared. So 3s cubed over 4t squared. For b, we have 5x over 4y squared times 2y over x squared raised to the 3rd power. So again, we're going to raise both the numerator and the denominator to that 3 as a power. We're going to keep the 5x over 4y squared on the top, on the front. And this is going to be like saying 2y cubed over x squared cubed. So the 2y cubed is saying 2y times 2y times 2y. So this is going to be 8y cubed over x squared raised to the 3rd power is going to be x to the 6th power. Remember, we multiply those two. And we're going to multiply that by the 5x over 4y squared. So 5x times 8y cubed is going to give us 40xy cubed. And then the 4y squared times x to the 6 is going to be 4x to the 6y squared. Now, we can also simplify before we multiply, just like we normally would. The 5 and the x to the 6, or 5x and the x to the 6th power, we can simplify those x's and take 1 away from that 6. The 4y squared and the 8y cubed, 4 and 8 share a common factor of 4, so the 4 would become a 1, the 8 would become a 2. The y squared you can take away from the y cubed. So then we're going to have 5 times 2, or 5 over 1 times 2y over x to the 5th. So this 5 times 2 is 10. Keep the y over x to the 5th. So 10y over x to the 5th. You could have gone ahead and multiplied. Once you got to the 5x over 4y squared times 8y cubed over x to the 6th power, you could have multiplied straight across and then simplified from there as well. I just don't care for doing that because I'm working with bigger numbers, and I like to work with smaller numbers. So if we look at c, we have a squared b over c cubed, all raised to the 2nd power, times c to the 6th power over ab cubed. So we're going to we're going to raise the a squared b to the 2nd power, as well as the c cubed to the 2nd power, and then multiply that by the c to the 6th power over a b cubed. So raising that a squared b squared to the second power is going to become a to the fourth power b squared. And then that c cubed raised to the second power is going to be c to the sixth power. We're multiplying this by c to the sixth power over ab cubed. So if we look at this, the c to the sixth power can cross simplify with the c to the sixth power. They're both going to turn into 1. The a to the fourth can simplify with the a, and we're going to subtract 1 from the fourth power. Then that b squared can simplify with the b cubed. We're going to subtract 2 from that third power. So this is going to turn into a to the third power over 1 times 1 over b. If we multiply these straight across now, we have a cubed over b. And if we look at d, we have z to the power of n raised to the third power over z to the power of n times z to the third power. So we can go ahead and simplify each part here. With the top, we're going to multiply that n times the 3, because remember, when a power is raised to a power, we multiply those powers. So this is going to be z to the power of 3n. On the bottom, remember, when we're multiplying, we're going to keep the base, add the exponents. So it's going to be z to the power of n plus 3. Can you simplify anything from here? Well, think about it. When you have the same bases, you are going to subtract those powers if they are over each other. So we have the same base, which is the z. Now subtract the 3n minus the n plus 3. You see how I put parentheses around that? You have to remember to distribute that negative in. So this is going to turn into z to the power of 3n minus n minus 3. So that 3n minus n is 2n, so z to the power of 2n minus 3.